ಆಗ್ತಿಲ್ಲ ಆ್ಯಕ್ಚುಲಿ. ಹಾಗೆ ಬರ್ತದೆ. ಚೆನ್ನಾಗಿ ಗೊತ್ತಿಲ್ಲ. ಈ ಥರ ಬರುತ್ತೆ ಸರ್. ಯುವರ್ ಸಿಸ್ಟಮ್ ಸೆಟ್ಟಿಂಗ್ಸ್ ಟು ಮೇಕ್ ಶೋರ್ ದಟ್
ಇದೆಲ್ಲ ಹಾಗಲ್ಲ ಮುಂಚೆ ಬಂತ
ಇಲ್ಲ ಸರ್, ಮುಂಚೆ ಕ್ಲಾಸ್ ಮಾಡಿದ್ದೀನಿ ನಾನು. ಇಲ್ಲೇ ಕುತ್ಕೊಂಡು ಮಾಡಿದ್ದೀನಿ. ಮೊಬೈಲ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಮೊಬೈಲ್ ವಾಯ್ಸ್ ಕೊಡ್ತಿದೆ. ಪ್ರಾಬ್ಲಮ್ ಏನಂದ್ರೆ ನೆಟ್ವರ್ಕ್ ಆ ಕಡೆ ಬರುತ್ತೆ. ಅಷ್ಟೇ. ಅದೇ ಅವಾಗ ಅದನ್ನ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಈ ಸಿಸ್ಟಮಲ್ಲಿ, ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅವ್ರು ಮಾತಾಡೋದು ಕೇಳಿಸುತ್ತೆ, ನಮ್ಮ ಆಗಿಲ್ಲ ಸರ್, ಆಗಿಲ್ಲ. ಅದೇ ಬೇರೆ ಸಿಸ್ಟಮ್ ಚೇಂಜ್ ಸರ್, ಹೋಗ್ಲಿ ಬಿಡಿ. You're getting my voice, everyone? Hello. Okay. What audible or not? ಏನು ಸರ್, ಮಾತಾಡಿದ್ರೆ ಇವ್ರಿಗೆ ಕೇಳಿಸ್ತಾ ಇಲ್ವಾ? ವಾಯ್ಸ್ ಬ್ರೇಕ್. ಓಕೆ 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 ಓಕೆ, ಜಸ್ಟ್ ಅ ಸೆಕೆಂಡ್. ಓಕೆ ಎಷ್ಟು ಫ್ರೆಂಡ್ಸ್ ಪ್ರೈಸ್ gmail.com.
ಎಲ್ಲಿದೆ ನಮ್ಮ ಲಿಂಕ್ ಲಿಂಕ್ ಎಲ್ಲಿದೆ ಹೇಳಿ
ಅಲ್ಲಿಲ್ಲ ಇಲ್ಲ
ಲಿಂಕ್ ಓಪನ್ ಮಾಡಬೇಕು
ಲಿಂಕ್ ಓಪನ್ ಮಾಡಿ ಅಲ್ಲಿ ಮೀಟಿಂಗ್ಸ್ ಕೊಡಿ ಇದು ಈ ಮೀಟಿಂಗ್ Okay, now is it clear? My voice is clear? It's clear? Yeah. Yeah, you're all right. Last time, what is it? Okay. ಅಂತ I should download presentation. ಸರ್ ರೆಡಿ ಮಾಡ್ಕೊಡ್ತೀರಾ? ಇಲ್ಲ ಸರ್, ಈ ಮಾಡಿ ಸರ್, ಇಲ್ಲಿ ರೆಡಿ ಮಾಡ್ಕೊಡಿ. ಅಲ್ಲ, ಇದು resolution download ಆಗ. ಅಲ್ಲೇ ಇರಲಿ ಬಿಡಿ ಸರ್, ಆ ಸಿಸ್ಟಮ್ ರೆಡಿ ಮಾಡಲಿ ಬಿಡಿ. ಸರ್ ಅದು ಆನ್ ಮಾಡ್ಕೊಡಿ ಸರ್. did you? ಹೋಗ್ಲಿ ಬಿಡಿ ಸರ್, ಇಲ್ಲೇ ಹಾಕೊಂತಿರೋದು. ಕತೆ ಕರ್ಮ. ಬೆಳಗ್ಗೆ 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 ಇಲ್ಲ ಬಿಡಿ ಸರ್, ಅದು ಇಲ್ಲೇ ಮಾಡ್ಕೊಂಡು ಒಂದ್ರಲ್ಲಿ ಬರಲ್ಲ.
Okay, is my voice audible right now? A message over here? Yeah. Okay, the last one. Okay, sir. Is my voice audible? Yeah, okay, pa, fine. Sorry for the delay. No, I have a small problem with my speaker and my system. Let it be. We'll start presentation right now. Okay. Okay. See, in the previous class, we have thought about the very important concept of, what is said to be a bus, right? So, bus, what is a bus? And, the main use of bus, why we are going to use the bus and all we have discussed in the previous class, isn't it? Okay. So, and we have already discussed arbitration also, and asynchronous and synchronous. Both the concept we have already discussed in the previous class, isn't it? Okay. Okay, my presentation. Yeah. Okay, everybody got the presentation, isn't it? Yes. Fine. So now, what is our today's topic is interface circuits. Okay, it's very important. The topic is very important. If you have any queries, you can pose over here. Any voice problem, anything you felt some problem is there, you can pose a question over here. I'm able to see. Okay, so in the today's topic, we are going to study an interface circuit. So it's quite related to your electronics based concept, but we don't want much, depth knowledge is not required here. So what we mainly needed is, so how the interface between our input output devices to our system. Okay, that's all. So if you want, I'll write it here, one small diagram, so that you can understand easily. Suppose you see here, whenever I'll take, this is a devices, right? So with this bus, okay, okay, even I'll put for record. Yeah, just a second. Okay. Yes, fine. So what we are getting is, we are going to study, there is a number of input output devices are there. They are all connected to the, to this particular bus, right? So this we are already aware of it. I think you are already aware of this, right? So we have a memory or we have a processor here. Okay, so we have a memory available here. So you have n number of input output devices here. This is one input output device. This is one input output device. This is one more input or output device. Okay, any device you can consider like this. Okay, so now processor to input output device or processor to memory, I want to transmit a data, isn't it? I want to transmit a data. So what I should do? So I will take the data. Okay, suppose I want to transmit data from processor to memory. So what I will do? I will take the data from processor through this bus. I will transmit to the memory. Okay, that is what our arbitration and all, whichever we have discussed in the previous class. So in the today's topic is interface circuit. So interface is nothing but mainly in between your input device to the processor. Okay, your input output devices, how they have connected to your system. Okay, suppose if you say this is between these two, processor and input output device, there is one, the circuits or integrated circuit or an interface circuit which works as an intermediate between processor and input output devices. Okay, so it acts as an intermediate person. Okay, so it will make you a proper proper channel to make a communication between processor and input output device. I hope you are Okay. Okay, fine. See, a small issue is there here. A few problem with the network. Sorry for the interrupt. Okay. Anyway, ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ. We have to somehow manage. Okay, this is your interface circuit. So how the interface circuit looks, okay, that you can make out here. I think you are able to see the interface circuit, right? So here the yellow colored part, see here, this yellow color part is said to be, you know, said to be an interface. Here, this is the interface. This is the interface. You see to this? This is the interface part, okay? So what is that interface part consisting of? So it is mainly consisting of, okay, so data in register, which holds the data, and SIN, that means sign bit register, that is one more data bit space, and this is mainly used to provide communication between processor and the keyboard. See here, this is your processor, this is your keyboard. I think this is a processor, this is the keyboard. Okay, so between these two, processor and the keyboard, we are going to provide an intermediate or an interface circuit. Okay, so this completely known as interface circuit. Okay, it is mainly consisting of, one is input interface, along with that, encoder and debouncing circuit. Okay, so this both will be said to be a interface circuit. Okay, so what's the main use of interface circuit? The main use of interface circuit is in order to send the data from the keyboard to processor, or from processor to keyboard. Okay, so keyboard will be what? One of the input device. Okay, so it could be an output device. It's not a matter that it could be input device or it could be output device. Anyway, I want to make a communication between processor and the input device, or processor and the output device. Okay, in between these two, some mediator, okay, some interface circuit is required, that is available here. Okay, so the main use is, what I will do, whenever I enter through the keyboard, some data I will enter. See, suppose I will type here data A, alphabet A. As soon as I type the data, I'm going to press the keyboard. I press a key, A button I used to press, isn't it? So as soon as I press the data, it will be encoded here. What's the meaning of encoded? Encoding means your data will be converted into the ASCII value of capital letter A. Suppose you assume that the capital letter A is having the ASCII value 65, that means your data will be converted, instead of A, capital letter A, instead of A, it will be converted to 65. That is an encoder will do. Okay, so now debouncing circuit. Debouncing circuit means, so whenever I press the signal, whenever I press the button, there may be a possibility that the same character may be, due to some circuit interfacing, there may be some bouncing will be take place. That means what? A may be displayed two or three times. Even if you press one time inside the circuit, there may be possibility of getting the data duplicated or okay, triple the data. So if such case has happened, I'm going to debounce it. Okay, if I press one time A, I 100% I'll get only one time A. Okay, even if some issues available with bouncing, so that will be debounced by the circuit, that is debouncing circuit. Okay, so you will get your data 65. That data we are going to pass it into the register. Which register? Data in register. Okay, so I'm going to press here the data A, that is nothing but 65. Okay, it looks like 65. So that data, as soon as the keyboard has stored in this particular interface device, okay, with a SIN bit. That means what? There is one sign indicator, that is nothing but what? 1. What it indicates? So the data is there in the keyboard. Okay, so this enables one of the request. What request? A request to the processor. What request? Okay, there is some data in the keyboard, please read that data. Okay, now the processor will make one communication. What communication? A communication said to be a asynchronous communication. The asynchronous communication is nothing but slave ready and master ready both should be enabled. Okay, master ready means your processor is ready. Slave ready means your keyboard is ready to send the data. Okay, both are ready. As soon as both are ready, there will be one more signal known as read or write. Okay, read or write. See here, whenever I will say read or write, okay, just see this. Okay, suppose the signal is 1. Suppose the signal is 1 means, is it read or write? Can you give me the answer? Whenever I will say read or write, okay, in this read or write signal, the signal is 1. If I say the signal is 1, so now whether I should read the data or I should write the data, that's what my question. Read the data, very good. Yeah, suppose if it is 0, what's the meaning now? What's the meaning? Suppose if it is 0, if the signal is 0, so it indicates right. How it is right? For example, see here, if you want to just put it here, see in this, see read or write. Okay, I'll put 0 on this. See, above the r, if I put 0 means okay, read, don't read. Okay, suppose this 0 I'll put above this right. Okay, 0. Okay, negate means what? 1. That means what? Write it. That's what it indicates. I hope you are clear. Okay, whenever it is 0 means, whenever it is 0 means whichever is the data is negate is there, no, that will be read. That's what it is now. So read will be read because the processor should read the data. So the processor will read the data, and even I should know at what address I have the data, isn't it? So for data in, there will be one small address will be there. So I will go to this particular address and I'll access the data. Okay, so and that data will be copied here. See, the data will be copied to my processor. I think you are able to understand this circuit. Okay, so this will be an interface. You are able to see this. This this is said to be an interface between what? Your input output device to the processor. Okay, I hope you have understood. Suppose in case if I say this is printer, assume this is not a keyboard, this is printer. Printer means what I could do, it's very simple. So printer is nothing but, so I should copy the data to the printer. That means what? I should send the data from processor to your printer. That's also same thing. Okay, a little bit small change will be there. What is that change? Everything is changed here. Only thing here, instead of data in, I'm going to write here the data out, isn't it? Data out, this register will be enabled, and this is, instead of s in, this will be s out. Okay, and this is instead of input interface, it is known as output interface. That's all. Okay, very simple. So it will take, the processor will give the address. Okay, so from this processor will give the data, so that data will be copied it into data out. From data out, it will be copied it into printer. That's all. Okay, so that is said to be a very simple intermediate circuit between your processor to the input output devices. That's all. Okay, but you should know one thing, here it is asynchronous. Asynchronous means what? Slave should be ready and even master should be ready. That you are already studied in the previous class. Okay, now that's what, it's very simple. Now just see here. So here, to do this data transmission, suppose you assume I'm going to send the data. What data? I'll take some bits of data I will take. That's better. Suppose this is processor. I just want to read the data from the keyboard. 1 0 1 0. I've entered 1, next is 0, next 1, next 0. So first I want to take this data, isn't it? When I take this data, see, I'll read first 1 bit. Okay, encoded. After encoding, data will be passed to data in. Okay, 1. So next 1 will be passed to my processor. Okay, next time what? 0. Next time 0. So 0 will be encoded. Next data in 0. Next it will be copied to my processor 0. Okay, next bit 1 encoded. Next 1 bit. Next 1 is read by the processor. Next last 0. Next is 0 here in the data in register. Next will be 0. Right? So I have copied 1 0 1 0. So like this, 1 1 bit I am going to read. Okay, so first one bit I'll take, next one bit I'll take, next one bit I'll take, next 0. Okay, like this, 1 0 1 0. So if I take one bit sequentially, next sequential bit, like this. So this kind of, taking the data, that is said to be a serial port. Okay, that is said to be serial port. Serial port means reading one bit of data. Okay, one bit at a time I'm going to read it. Okay, suppose I'll take parallel bit, parallel, parallel port. Parallel port means completely 1010 all data simultaneously I will take. 1010 complete data I will take. Okay, in case even 1010 along with that, if I type one more 1100, so this data will also, read simultaneously. Parallelly I'm going to read the data. Okay, that is said to be parallel. Parallel means, so all the bits of data parallelly I'm going to read. Okay, all the bits. Suppose 8 bits are there, means 8-bit parallel port. Okay, so I'm going to it is possible to read all 8 bits at a time. That means what? One, suppose 1010 1111. So all this 8 bits of data I will read simultaneously. That is said to be a parallel port. Okay, suppose in case I'm going to read one bit, first bit one time, next bit another, next time, like that, one bit at a time, that is said to be serial port. Okay, so that is what the main concept here. There is two things are there. One is parallel port, one is serial port. Okay, now we will just see. So this same diagram only with the parallel port, they have described it in the slide clearly. And here one thing is very important. See here, you can see here one valid. See, in the previous semester exam, I've seen the same question has been given. Explain the parallel port. Very, they have asked it in the exam actually. See here, valid. So what is this valid means? So by default, it will, it indicates you are this particular keyboard is ready. Keyboard is ready means what? So the keyboard is read the data and the data is A. It is ready to send you. Okay, it is like by default, it will say some data is there within the keyboard. Valid means some data is there within the keyboard. Okay, that is what valid. Okay, then only I'm going to copy the data into data in. I hope you are clear. Okay, so whenever this is valid, then only data in will be utilized to put the data, and SIN bit will be enabled by 1. That you should know. This while you're explaining, you have to give a small explanation for valid, why it is valid signal. Okay, so like that we have a parallel port. And here input interface circuit. So how the data will be transmitted, so with respect to your keyboard to processor, right? So the same thing. So see this diagram, the same diagram only with some, so what and all circuits we have utilized here. Okay, so what we'll say, we are going to use AND gate, OR gate, NOR gate and all. No, so that internal a little bit information has been provided, so we may not require a very depth, but to the point, we are just I'll explain you that. Okay, so as per the requirement, I'm just going to explain you. Okay, so I think you're able to see this particular slide, right? You're clear with this slide? Okay, yeah, just a second, I'll put it for yes. Okay, I think you're able to see this slide clearly. Is it clear? Yeah, is it clear now? Clear? Is this particular slide is clear? You're able to read each and every signal information, you're able to read? Yes or no? Yes? Yeah, okay, fine. So now just to see, I told you this is a first explanation of parallel port. Parallel port means I'm going to simultaneously read every bits of data. Suppose I will say I'm going to transmit some bits of data. So that is 7 bits. Assume here 7 bits of data I'm sending. Okay, 7 bits is 0 1 0 1 1 1 0. Okay, something like this, 0 1 2 3 4 5 6 7. Okay, all these 7 bits of data I just want to Okay, I just want to read by the processor. Okay, now what the processor will do, the processor, where is the data exist, okay, that address will be provided. Okay, assume here I have a data in register. Inside this data register I have a 7 bits of data, that is what 0 1 1 1 0 1 0. Okay, so I should know the address of this data in register. Okay, so data in register will be what, your interface circuit which is attached to my keyboard, isn't it? So now what I should do, I have to put the address here. So here you can use the address for 0 to A1, 2, 3, 4 like that till 31 bits. Okay, so address decoder I'm going to enable. Now as soon as I enable the data, see here, as soon as I provided the address, what I should do, I'm going to give one signal. So A0 will indicate whether I should I should read the data or I should write the data. So this is what a read operation. So I have to make it as 1. If it is 1, so my read signal will be enabled. As soon as read signal will be enabled, so it will indicate that even slave is ready. Okay, slave is ready, and here data will be read the data. So as soon as read the data, so it indicates that by default SIN SIN sorry, that means status input signal will be 1. Okay, as soon as this is 1, the data will be read. Okay, the data will be read and it is passed to my processor. Okay, all the data will be read and pass it to my processor. Okay, so this is what an input interface circuit with respect to some the gates, AND gate, OR gate and all. Okay, so that's what simple diagram consisting of address decoder, SIN bit, reads status and read the data signal, and status flag. What's the status flag? Status flag is indicates whether if it is read means it's status flag, yes, read the data, otherwise it should be a 0. That means what, your keyboard is having the data. If keyboard is having the data, it should be 1. If keyboard don't have any data, it should be 0. Okay, so that is how I am getting because of this valid bit, valid signal. Okay, so this is what a simple diagram to explain you that regarding input interface circuit for a parallel port. Okay, now just see the same thing only. So this is for data out. Okay, same thing, data out. I told now already. Data in means what? So I am reading the data to the processor, right? So from input device, I'm going to read the data. That is what input interface. Output interface means the simple thing. So from processor, I have the data A here. I want to copy the data to the printer. Okay, for that I required a interface. So this interface is nothing but just so send the data. Data is what? A. And what's the address? So address. So where I want to put the data. So that address also I will send it. Okay, now the A will be copied it into my data out register. Okay, now whenever I send the data A to the data out register, now can you tell me what could be my S out? What could be my S out? Shall I put it 0 or 1? Yeah, exactly. The data out. Okay, initially it will be 0 by default. Now I will enable it to 1. Okay, and here, so now read or write. Can you tell me what could be the read or write? It should be 0 or 1. My processor should enable read or write by what signal? 0 or 1 now? See, I'm asking you this signal. My processor wants to send the data to my printer. Okay, so write the data to the printer. Now I'm asking you whether that signal should be 0 or 1. Exactly. Yeah, Kavya has given the answer. Exactly, it's 0 only, right? Why it is 0? As soon as it is 0, see here, if it is 0 means by default 0 negate, right? If 0 means read will be 0, obviously. 0 negate means 1. That means write will be enabled. When the write will be enabled, I'm going to get the printer. The data should be read. Okay, the data should be write on the printer. I'm going to put the data to the printer. So that is what writing the data. What data I'm writing here? A. Okay, and here also this is asynchronous. I told you already. Asynchronous means what? Slave should be ready and master should be ready. Both should be ready. Okay, so my master is processor, it is ready, and slave is also ready. Okay, and here you can ask me one simple question. What is it? Simple question, ma'am? Here we don't have any encoder or decoder. See, in the previous example, we have a here we have an encoder. I think you are able to see this in the input interface. in this, reading the data, I'll be having encoder and deep bouncing circuit, isn't it? Here, this is there. But here in the output, I don't want to decode anything. Okay, that is why. So I have not included any circuit over here. Okay, decoder or debouncing circuit is not required. So just I will send the data and here valid. So valid indicates what? Processor is send the data to you. That is said to be valid. And idle. Idle means what? See, please make a point here. Idle means if the printer will say I am idle, then only it is able to print the data. Are you agree? If the printer will say I'm busy instead of idle, if it is say I'll busy, what it indicates? I'm already printing some data, wait for some time. Okay, you please wait for some time, I'm already busy. If it is idle, idle means what? I'm free now. If you give me some data, I will print. I hope you are clear. That is what my idle indicates. Valid indicates means what? Valid indicates data is there in the this particular register, data out register, that is said to be valid. Okay. Oh, that's the things. So I don't want to make very much elaborated explanation. So this much concept is enough. Okay. I think by this we have an output interface. So this is also very simple. What we should do is we have a printer. See, you should know the 4 diagrams are important. First diagram is parallel port with input interface circuit. Next, writing the data. See this diagram. Okay, writing the data via parallel port with output interface circuit. Okay, this diagram is again. So I am writing the data to the printer, right? So what I should do now? So it's very simple. I think you can make out here. First, I have to give the address. Processor has to give the address. So where I want to write the data. Okay, that is very, very important. So as soon as I given the address, so here I should give the signal whether I should write the data or read the data. So what I should do, I should write the data. So that is why. So it will indicate that instead of read status, by default it will take it as write status. It will write the data. So as soon as I given as write status, what I should do, I'm going to load the data. Okay, load the data indicates I'm going to write the data. So here, as soon as I load the data to my register data out, so there will be an S out will be enabled. What's my S out? S out will be 1. Okay. So now that data will be, will be copied to my printer because of what? Because of a signal of idle. Because of idle signal and because of valid. Valid means what? Processor is given the data. Now printer is received the data. Okay. It's something like handshaking again. Master ready and slave ready. Something like indirectly it indicates master ready and slave ready. Okay. So already the signal is available here. See here. Same signal. The same thing will be repeated one more time here. Okay. So now as soon as I got the data, I'm going to print the data on the printer screen. Okay. So your data 0, 1, all 7 bits of data will be printed on the display device. Okay. Or on a monitor or on a printer. Okay, so that is what with respect to output interface circuit. Okay, so you should remember 4 diagrams. Okay, so this is for what? Parallel port. Parallel port means what? All bits of data, okay, will be simultaneously read by the processor or write by the processor. Okay, it's very simple. Then you can make out here on combination. On combination, suppose I will read the data and I will write the data. Processor will read the data, simultaneously it will write the data. Okay, how the circuit looks like, just see here. I think you're able to see the diagram. So this is data in. See here. First I want to see the address. So from where I should read the data. That is why the address will be available here. See here, address. Okay, as soon as the address will be given, what I should do, I should read the data. So whenever the address will be read, so here will be data will be enabled as read. Okay, so as soon as read button will be on, by default you are going to make an input status. Your input status 1, that is be 1. Okay, if SN bit will be 1, we copied it into the processor. That is what data will be copied to the processor. So this is processor. It will take your data to processor. Okay, there is another work is there. That means the same data, whatever you have read, you copy the data to the printer. Okay, for that purpose, what I should do? So I'm going to enable here write. I'll enable. As soon as I enable the write bit, you're going to make your S out. S out will be enabled. As soon as S out will be enabled, by default, there will be an handshaking. That means what? Valid and idle signal will be enabled. This is valid, this is idle, both are enabled. As soon as both are enabled, your data is from the processor will be copied to the printer. Okay, so that is what your data will be copied. See here, the same data, whatever you have read now, the same data will be copied to the data out. That means what? This will take you to printer. This will take you to printer. Okay, this is the integrated circuit of both read the data by the processor or write the data to the printer. Okay, so this is an integrated circuit. I don't know, in exam they may ask separately. Give the, see, your question will be something like this. Explain the parallel port for reading operation or input operation, okay, with the interface circuit. Means you have to write this diagram, this two diagram. Input read the data with parallel port means this diagram, with the interface circuit means this. Okay, two diagrams. Suppose second possible question is explain the parallel port for output operation with the output circuit interface. That means this diagram, okay, with this this diagram. These two diagrams you have to explain. Okay, suppose last question, give the integrated input, reading the data or writing the data to the printer using the parallel port. Okay, that with input with integrated circuit, that is very important. Then you have to give this particular diagram, both. Okay, both input read the data, write the data. Okay, that is what this diagram. Okay, this completes my input to interface part. Okay, only you have some 3 questions is possible. You can choose and study. Okay, plan properly and study. Okay, so this is also the same diagram, the same diagram only. So they have given, see, data in means reading the data out means writing the data to the printer. And here I'm going to do the operation, how to do the writing operation, how to do the reading operation. That will be under the control of the very important register, that is data direction register. Okay, the data direction register will be mainly used as a controller. Okay, this is a controller, it acts like a controller, or if you want, I'll write it as a control unit. Okay, I can call it as a control unit. The control unit will be mainly utilized or mainly used to give the direction to my processor. What direction? Either processor should read the data from the keyboard or the processor should write the data on the printer. Okay, so how to do that? That will be enabled by my data direction registers. Okay, which will be having some status and control information. That means status control means what? So the mainly it will explains you. See here, the status will be, you can make out here, ready and accept lines or handshaking. Okay, and here C1 and C2 control the interaction between interface circuits and input devices. Okay, mainly it is used for valid. Okay, valid signal and idle. Valid means what? Your processor is ready. Idle means what? Your printer is ready. Okay, again, valid means what? Processor is ready. Idle means your input device is ready or not ready. Okay, so these signals will be mainly utilized. And we have some registers also. See, what are the registers? We can write it as read or write. We can make ready, master ready, slave ready. Okay, and address bits enabled. And we have some registers, signals such as RS0, RS1. If you want, you can see one more concept, that is ready and accept. Okay, so whether you want to whether you are able to read the data, processor is ready to read the data, then it will be ready. Accept means after I'm getting the data, so whether I should accept the data, so that is what the accept. So accepting and ready. Okay, so like this we have some registers will be utilized to provide a guidance. Okay, so it's like a control signals. Okay, so control signals will be it acts like a control unit, so that is known as register select. Okay, you can select any of the registers. Okay, I think you are able to see this, and we will call another name. Okay, there is one more name is there. So for this particular data direction register, that is known as DDR. DDR means data direction register. Okay, data direction register will be the one who will control your interface circuit, either to read the data or to write the data. Okay, I think with this I don't want to elaborate much. Just as with the required concept, I have explained this particular scenarios of parallel port and serial port. How the serial port looks like? Suppose you see the serial port, how it looks. See a little bit change here. You can see here there will be a little bit change in the uh, diagram. How it looks. See here, your serial input means you will send the data serially. See here, serial input. One bit at a time. See here, this word is very, very important. Input shift register accept input one bit at a time. That means what? Even though you have sent, see, 10 10 101, even if you send 7 bits of data simultaneously, parallelly, it won't read all bits of data simultaneously. What I should do? It will read one bit at a time. Okay, it will read one first, next 0, one bit. First it will take one, it will send one. Okay, like that. So next 1 0 1 0 1. Okay, serially. That means what serially means? One bit first, next bit next time. So next bit will be next time. So like that, serially it will take one bit. Okay, data. So that will be a copy to my processor. Okay, so data in means I am send the data. Okay, so if it is reading the data, so reading the data means what? Processor should read the data. Whenever it is processor will read the data, so it will take you to the processor. This is what my processor exists. Okay, suppose write the data. That means what? I am supposed to write the data to the printer. So what I should do now? So the same data will be sent. That means data out. Data out means the data will be sent to out, sent via printer. So printer here. So data out means I'm sending the data to the printer. Data in means I've received the data from the keyboard. Okay, so your processor available, your printer available. I think you are able to understand this. And here also we have some controller. What's the main intention of controller? So to control what to which data should be enabled, which signal should be enabled. So that is what. So we are going to use some signals here. RS0, RS1. So this is mainly used to make master ready and slave ready. Okay, so these signals are mainly utilized for whether the master is ready, that means your printer is ready, or your keyboard is ready, or your processor is ready. Okay, and address. So what is the address? Okay, from where I should read the data or to where I should write the data. Okay, and here also read or write signal and ready. So ready means sending the data, accept means received the data. Okay, so that is what. And here also we have some status and control. Mainly the status and control is mainly utilized for the clocks. I'm going to use some clocks over here. Okay, so whenever I'm going to use here a receiving clock. What's a receiving clock? So I've told you already. So whenever your clock has been set, so that means what? Your data will be your data transmission will be start. Okay, with the time t0. So I think you remember that is 0. Next clock, next 0 to 1 2, like this we are going to provide some clock. Okay, so within that given clock your data will be transmitted or your data will be received. Okay, so like that we have some information over here. This is what serial port. Okay, and there is a simple concept over here, very important concept. I'll just show you that. See, this is processor available. Okay, so this is your devices connected. Okay, this is your one bus, this is one more bus. I'll be using here two buses now. Initially how the bus looks like, Bus will be like this. This is processor. This is memory, right? This is memory. This is processor. And for the same bus, I have connected all my input devices and output devices. Input device, output device. Input device, output device. Okay. So there will be a problem here. What's the main problem is, so as soon as you transmit the data, there will be a bulk amount of data maybe exist. Okay, when there is a bulk amount of data you need to transfer with this only one bus. Okay, it is not sufficient. With only one bus it is not sufficient to manage all the data transmission between processor to memory and between processor to all other input output devices. Okay, there may some delay may exist. In order to solve that, what I will do, I am going to use here and one, another bus. Okay, so another important bus we are going to use here, that is known as processor control bus. Okay, so you are able to see this one bus, that is nothing but see a PCI bus. You are able to see this bus. See, that is one this bus. Okay, this is your another bus, that is known as processor bus, already exists, but here new one more bus we have incorporated, that is PCI bus. You are able to see this? You know, type me yes or no. Yeah. Yes, right. You are able to see this. So this PCI means, what is this PCI bus? So additionally bus I have incorporated here, that is known as peripheral component interconnect bus. Is I'll write it here. Peripheral 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 component 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 interconnect 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 bus. Okay, so what is this bus? Peripheral component interconnect bus. That is what your PCI bus. See, the main intention is what we required us whenever we are sending the data. Okay, either we are going to use parallel circuit or serial circuit. Okay, any circuit I'll use, parallel port or serial port. With that serial and parallel port I will read the data or write the data. But what is the problem is, if I am having only one bus, see, if I am having only one bus, so simultaneously the data transmission, particularly, even I can include a DMA here, right? Direct memory access controller, right? So suppose I'm transmitting the data from DMA controller to some output device, or from processor to input device, or from input device to memory. With this existing one bus, you're not able to, send your data or receive your data. Okay, particularly vast, a bulk amount of data so fast. You're not able to send the data. Okay, in order to provide your data transmission, a bit faster, I'm going to incorporate an additional bus here. What is that additional bus? For this existing bus only, I'm adding one more extra bus. Okay, so that bus is known as PCI bus. See here, PCI bus. This PCI bus is said to be peripheral component interconnect bus. See, you know peripheral devices. Peripheral device means what? Additional devices. Exactly, right? So additional accessories. Okay, that means what? Some of the additional memory, some of the SCSI controller. I'll tell you what is SCSI controller. Okay, later. We have a topic over there. Okay, then we have some Ethernet interface cable, then USB controller, then interconnect some other devices. Okay, so like this we have all these devices. I'm going to communicate. Okay, data should be received. See, I am going to receive the data from disk, CD-ROM, keyboard, some game, like this. I'm going to accept the data from many other interconnected devices. Okay, so I should take the data from this PSI bus, via this PSI bus, to my processor bus. Okay, I'll see additional memory from here to, there is one bridge is there in between processor bus to PCI bus. Okay, via this bridge I'm going to access the data. So bridge is nothing but what is it, it is also an interface circuit. Okay, it will provide the communication between processor bus and the PCI bus. Okay, so these data will be passed on to my processor or to my memory. Now, suppose when I'm sending the data between processor and memory, do I require PCI bus? If I'm transmitting the data from processor to main memory, do I require PCI bus? Yes or no? Yeah. See, Gaurav has given a given an wonderful question. See, Gaurav, whenever we are going to have a devices, if you just remember your laptop, you just take your laptop. We have n number of ports are there, right? We have a USB cable port is there. Okay, then you can connect your normally suppose you are going to use your video game and all, no, you are playing with that, so extra additional input output devices you want. Okay, for that also you have some port, different port is there. Okay, and you have normal or mouse. Okay, so other for that also we have another port. Okay, so there will be mainly we have some discrepancy in the devices. Okay, so all these devices are, there are many discrepancies are there. So we require a proper software to receive the data, even though your devices are with many hardware discrepancies, isn't it? So we require a software. So for devices only, we required one intermediate software to coordinate all the devices. Can you imagine for for the buses, processor bus to your PSI bus, I required one interface software, isn't it? It's not like a bridge. It's a software actually. The software which is mainly used to take the data from the PCI bus and transmit or connect it to my processor bus. That's all. Okay, so there will be a small discrepancy. Okay, when compared to your processor bus, so your PCI bus may be quite different. Why it is quite different? Your PCI bus will have large bulk data transmission capacity. Why it is a large bulk data transmission capacity? Because DMA controller will take your data from the disk to the printer, or disk to one of your another disk, or you can copy your data from this disk, see here, this disk to another ethernet interface. Okay, like that you can take bulk amount of data. So okay, when compared to this bus, the processor bus is quite different. Just see to this. Suppose, okay, let me clear all this. Suppose you assume, yeah, just see here, I'm going to receive the data from the memory. Okay, additional memory. Okay, so probably I'll consider this as one of the random access memory. So this is main memory. So read only memory. Okay, if you want flash, I'll take flash memory. Okay, flash memory. From this, I want to send a data to my processor. So what I should do, I'll take this data. I'll be available. Okay, I'll just stand here. Simultaneously, what I'll do, I'll put one pen drive. Okay, USB. Data will be available here. I stand here. Now, these data, okay, see, these data, mainly, I want to send this data to my processor or to my memory. Assume right now, okay. So, what I should do, I can't take this data directly and I can pass, okay. Some intermediate, software or a intermediate what we will call a code of program is required to take this data. Suppose I'll take this data and transmit to the required person, whether it should be a processor or it should be a memory. It should send the data simultaneously. It take the data and pass from here either to processor or to memory. That's all its work. Okay, just select the data and pass on to processor bus, and that too in processor bus where I should reach my data, whether to processor or memory. Okay, so just it acts like an intermediate code of software. That's all. Okay. Okay, that's all, nothing else. Okay, so this is what the main work of my PCI bus. Okay, so we have this peripheral component interconnect bus. It's mainly used to transmit bulk amount of data. That you should keep it in your mind. Bulk amount of data. Okay, so bulk amount of data is transmitted. Suppose I've given one simple example to you. Suppose I told we have a that our college to KSIT college, we have a road, right? I told in the previous class also, we have a road here from our college to KSIT college. Okay, so if the traffic is heavy vehicles will move on this road, means what the people will do? Okay, many heavy vehicles will move. Okay, let me check any other alternate path is there. If there is no condition, I can go in that particular path. So what we will do, we'll go with some parallel road. What's it? Parallel road. There is one pipeline road is there to our college to KSIT, right? So this is what our Anand Sagar college to KSIT college. Okay, there is one more pipeline road is here. What we will think, okay, here is a heavy road traffic is there, means what I'll do, I'll choose some other path. Okay, so like that, if I provide two path, okay, one for processor to memory. So usually processor will require your data fast. It need to access faster. Processor should get the data as early as possible, right? Because processor wants the data immediately, because it needs to process, right? So if it is very busy with bulk amount of data transmission, your processor bus may be busy. You may not perform your data transmission between processor and memory. Okay, that's the main reason we are going to use another line, another road. Okay, another path, that is PCI, that is peripheral component interconnect bus. Okay, so I think we have two more other than PSI bus. We have two more buses are there. So probably it is again it is okay, SCSI one bus is there, and one more is there. We will discuss that other two buses in the next class. Okay, so if we complete the two buses, say like this, with the preliminary knowledge, that's fine. Okay, we can conclude our module. Okay, let it be. Any queries you have, please pose a queries here. By that time I'll take attendance. Okay, Asta.
Present, ma'am.
Asta present.
Yes, ma'am.
Asta is there.
Yes, ma'am.
ಬಂತೆ ನೋಡಿ. Okay, answer to the attendance. Asta.
Present, ma'am.
Okay, Yusuf.
Present, ma'am.
Abhijit. Okay, Abhijit absent. Abhishek.
Present, ma'am.
Abhishek Mishra.
Present, ma'am.
Okay, Adish.
Present, ma'am.
Aditya. Aditya Kumar. Yes, number 7. Okay, Aditya Pratap.
Present, ma'am.
Aditya Raj.
Present, ma'am.
Akanksha. Okay, Akanksha. Akili Chakravardhan.
Ma'am.
Akshat. Okay, Amog. Anaga.
Present, ma'am.
Anagashri. Anagashri is absent. ಇದ್ರೆ ನಾನು ಮಾತಾಡ್ತಿರೋದು ಸರ್ ಅಲ್ಲಿ ಕೇಳಿಸ್ತಾ ಇದೆ. ಅಲ್ಲಿ ಮೈಕ್ರೋಫೋನ್ ಆನ್ ಇದೆ ಅನ್ಸುತ್ತೆ. ನಿಮಿಷ. Ananya.
Present, ma'am.
Shivani.
Present, ma'am.
Okay. Ankit Kumar. Okay. Ankita. Okay. Anusha. Apurva.
Present, ma'am.
Okay. Apurvam.
Present, ma'am.
Okay. Aryan. Okay. Azim. Okay. Bhanupriya. Okay. Bhargav.
Present, ma'am.
Okay. Shri. Okay. Rishita.
Present, ma'am.
Okay. Rakshit. Okay. Chandan. Okay. Chandrakant. Okay. Chetana. Chirag. Chirantan. Chitra. Sai Sankirtana. Darshan. Deepa. Deepali. Sai Vasantareddy. Sai Vasantareddy. Shri Harsha.
Present, ma'am.
Shri Harsha.
Present, ma'am.
Okay, okay. Fabian. Okay. Suchita. Tushar.
Present, ma'am.
Okay, Tushar. Gagan. Okay, Ganesh. Ganesh. Gaurav. Okay, Ganesh, you're present. Present. Okay. Now, Sudhir. Sudhir. No. Pranati. Gurudarshan. Gurudarshan, ma'am. Hey, Gurudarshan is Gurudarshan is there. Okay. Okay. Vishwajit. Okay. Okay. Vishwani. Harsha. Okay. Harshit. Heb. Ishan. Ishita. Manasa. Jayam.
Present, ma'am.
Okay. Jeevan Raju. Okay. Jannavi. Jannavi.
Present, ma'am.
Anish.
Present, ma'am.
Okay, 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 Janvi. Anish. Okay. Bonesh. Okay. Kamal. Okay. Karthik. Karthik MR. Kavya. Kaja Mayud. Okay. Kushi. Okay. Pranav. Okay. Kritik.